Welcome again to Free Associations, the Medical Journal Club podcast for anyone who wants to learn more about that new blockbuster study that's hit the news. I'm Matt Fox, a professor of epidemiology and global health at Boston University, and we are here in the Boston University Godley studio. Before we get started, we want to take a second to remind you about the Population Health Exchange, Boston University School of Public Health's resource hub for lifelong learning. Find out more about it at populationhealthexchange.org, where you'll find this podcast as well as many other population health learning programs and tools. Today in our first segment, we will take on a new study that we're all hoping pans out because it asks the questions of whether eating chocolate can reduce your risk for a heart condition. And as you'd guess, it has gotten a ton of press. In the second part of the podcast, we'll talk about the difference between observational studies and randomized trials and why we love those randomized trials. And then in our third segment, our amazing and amusing segment, we'll talk about things in our field we've come across that made us happy. Now, before we get into our first segment, let me introduce you to my two partners in this endeavor. I'm joined in the studio by Dr. Chris Gill. Chris, can you introduce yourself?
Hey, good morning, Matt. I'm an infectious disease doctor and a clinical epidemiologist here at the Department of Global Health at the School of Public Health.
And Don Thea.
Yeah, and my name's Don Thea, and I'm just like Chris, but a little bit thinner.
Yeah, it has more hair too.
All right.
Although it's white.
Okay, let's get into our segment one, where we're taking on a new study using data from the Danish National Patient Register, something we'll no doubt talk more about, by Mostovsky and colleagues at various institutions, and this was published in the journal Heart. And the study looked at the relationship between the amount of chocolate you consume and your risk for atrial fibrillation, a common heart arrhythmia that puts a person at increased risk for stroke and heart failure. The title of the study is Chocolate Intake and Risk of Clinically Apparent Atrial Fibrillation, the Danish Diet, Cancer, and Health Study. Notably, by the way, it's a free online article if you want to read along at home. And we'll ask what they did, why they did it, what they found, and whether or not I am allowed to let my kids eat more chocolate.
And does it matter?
And does it matter? So before we get into it, let me give you some of the headlines that are coming out about this study, and you can imagine there are quite a few. So Newsweek says, want a healthy heart? Eat chocolate. New study finds. CBS News says, chocolate linked to lower risk for heart condition, AFib. Then the Telegraph says 6 bars of chocolate a week could cut risk of common heart condition. No idea where they got the 6 bars. And then the Harvard School of Public Health News, which I quote because that's where some of the authors were from, says eating chocolate may decrease risk of irregular heartbeat, which I find really interesting because the Harvard website, of course, is the one that qualifies this as maybe this works, whereas the rest seem to buy into it whole hog.
Mm-hmm.
All right, so to get into this, Chris, let me start by asking you to give us the overview of what the study was about, what they did, and what they found.
Sure, but I think it's probably fair to start by explaining to our audience what atrial fibrillation is. Mm-hmm. So for those of you who haven't studied heart physiology and anatomy, you may remember that there are those 2 chambers at the top of the heart that pump blood into the ventricles, which are the big workhorses of the heart that pump blood out to the rest of the body. And the atria are kind of like the priming pump for the main pump. And atrial fibrillation is when that priming pump stops functioning effectively, and instead the heart muscle sort of gets all tenderly and contracts in a sort of random and inefficient way. It quivers. It stops driving blood forward. And so the problem is not that this leads to a decrease, significant decrease in cardiac output, which it does to some degree. But the problem more is like if you're ever looking at like a waterfall and you look at the edge of like the waterfall and there's a little eddy with a leaf sort of spinning around and around in a circle and not leaving, going over the waterfall. Like there's billions of water just like feet away plowing over this waterfall, and yet right at the edge there's a little eddy of a leaf spinning, just not going over the waterfall. You're like, why doesn't it go? And this is kind of like atrial fibrillation, that you got little parts of the heart where the blood just does not go. It just sort of sits there and spins. Okay. And the difference is that blood, when it sits there and spins, turns into jello very quickly. And then if it suddenly finds its way into the circulation, whoop, off you go, and you get a stroke. And that's basically the problem with atrial fibrillation. fibrillation is that it's causing strokes.
All right.
That's
So
a bad thing.
what do they find here?
So here they were kind of looking at this interesting hypothesis as to whether eating chocolate could reduce your risk of having atrial fibrillation. And there were some theories as to how this might be, one of which is that it reduces inflammation in some way because of flavonoids in the chocolate, or maybe that it reduces oxidative stress, or maybe it changes the coagulability of blood, or maybe it does what I have a whole list of vasodilation. So it had like 4 putative effects that chocolate could do based on other epidemiologic studies. And so they use this cohort database from Denmark. So the Danish Diet, Cancer, and Health Studies, the name of it, has nothing to do with breakfast pastries. It has to do with the country, Denmark. So we just want to be clear about that. They're not advocating the eating of Danish.
They don't specifically say you can't have Danishes.
No, they didn't even comment on it, surprisingly.
I was really hoping that almond croissants would be beneficial because they're my favorites.
Assume, but that's French.
Yeah.
Anyway, so they had this cohort of about 57,000 people who were enrolled back in '93. Yes, it's a very big study. And Denmark's healthcare system is a little unique in that everybody is assigned a national identity number, which is linked to their medical records. And so wherever you are in Denmark, having any kind of event or treatment or vaccination or drug given to you or medical encounter of any kind that is linked by this one number and captured in Denmark's comprehensive data sets. So they are able to track you with this sort of, astonishing fidelity and completeness, right? And so it makes Denmark a very good place in which to do epidemiologic studies for this reason. So they recruit all these people between 93 and 97, and they follow them out through, I think it was 2009, so it was a good long time forward. And during that time, they looked to see if any of these people had episodes of new onset atrial fibrillation. And then they indexed that back, because at the very beginning of the study, they asked these people through a food frequency questionnaire, presumably a lot of different things that they could have eaten, but one of them was chocolate, and they asked them to quantify how much chocolate, like occasional chocolate or daily chocolate, on a range of chocolate exposure. And what they found, which made everybody very happy, because people like chocolate, is that if you ate more chocolate, you had less associated risk of atrial fibrillation. And it was even more profound when you were looking at this through sex. That the effect.
Say what?
The effect of chocolate exposure was more profound in women than in men.
Got it.
So there was like a 23% reduction in atrial fibrillation onset in women who ate lots of chocolate, as opposed to a 10% reduction among men who ate lots of chocolate. And that is the bottom line.
Okay,
so this is tremendously good news if it's true, because I personally like chocolate.
If it turns out to be true, we can all have a happy Halloween. So, Don, why don't you give us your take on what you think of the study?
Matt, interesting study. I'm not sure that I completely buy the conclusions of the
Wrong answer.
What I did like about the study was, as Chris mentioned, was the completeness of the data set. And it's something that
pretty amazing.
I think a lot of us in America would love it if there was a national identification number and we could hook that to outcomes that are identified for any hospital visit, any emergency room visit, any kind of a stay at all.
Unbelievable.
It's really pretty remarkable. However, I think that there are some issues in terms of the way the study was conducted, as far as I'm concerned.
What's your biggest?
Well, my biggest is that they asked at baseline about a whole series of covariates, and we've talked about this. We talked about this last time. And
Covariates meaning other variables.
Other variables that might also have an effect on atrial fibrillation.
Right.
And they had a fairly long list of covariates that they considered, but they didn't really have information that could contribute to those covariates. Like, for instance, sleep apnea is one that we know is a risk factor for atrial fibrillation. And while they identified that, and they identified the fact that sleep apnea is a consideration, it was not something that was elicited in the questionnaire or followed over time. So I think that along with a number of the other covariates that they couldn't control for, really calls into question the findings in my mind.
And so this is, as we talked about on the last podcast, this is the confounding problem. As I heard this described the other day, risk factors like to party together.
That's right.
So you get
especially when somebody throws in chocolate.
Exactly. So in this case, I wasn't thinking about sleep apnea, but I was thinking about other things that might go along with eating chocolate that might also go along with risk for, I don't want to say AFib because I don't really know the details, but certainly heart illness in general.
Well, the other really big one is caffeine.
Yep.
And caffeine is renowned for causing or exacerbating atrial fibrillation. And I think when you get into the data and you look at the caffeine consumption in some of these people, you can see that there really was a lot of increased caffeine consumption in the group that had the highest risk of atrial fibrillation, i.e. the group that did not take a lot of chocolate. They had more caffeine consumption than the group that consumed a lot of chocolate. And
So
that
do you think
immediately
that
makes me think that this is a spurious finding.
Do you think what's going on is that they're sort of substituting one caffeine source for another caffeine source? That is to say, they eat more chocolate and therefore they crave less coffee?
No. I think that that the amount of caffeine that is in coffee and soft drinks and other sources far exceeds the amount of caffeine that would be in the chocolate. Now that's if caffeine is one of the explaining variables. It could be the flavonoids that they talked about. I don't know. But caffeine, to me, is a really key player here. And
people like to drink coffee and eat chocolate together.
Yeah, and coffee contains
so good.
So much more caffeine than chocolate. And in fact, the chocolate consumed in this day in a study was all milk chocolate, which contains less caffeine than dark chocolate.
But I think that's another issue which they address, but they don't really get into details, which is they didn't ask specifically about dark chocolate versus milk chocolate. And
correct.
All of the studies that I've seen so far that attribute the beneficial effects of chocolate consumption on heart health relate to flavonoids, which are much more prevalent in dark chocolate than milk chocolate.
It's a concentration effect.
And so the idea that they have the sense is, from what they describe, that most of the chocolate being consumed is milk chocolate. And so it's hard to understand why they would see an effect for milk chocolate and when in fact it's dark chocolate you would expect where the effect would be. It also, just as somebody who doesn't know enough about AFib, it always, whenever I think about chocolate, I think, particularly milk chocolate, you're consuming fat and sugar along with the flavonoids. And presumably those things are not good for your heart. And so the idea that those are together and you can't really control for those two aspects, you can control for total calorie intake, but being able to tease out what is going on in chocolate when chocolate presumably is going to have both beneficial and harmful effects seems to me quite tricky.
Yeah, although I don't think milk and sugar are necessarily going to have an effect on the heart and the risk of atrial fibrillation.
Okay. Chris, what about you? What's your take on this one?
Well, it's interesting. I mean, the thing I always get sort of suspicious about in studies of these kinds is the healthy user bias, or the healthy user confounding. Okay. That is to say that it's not the chocolate per se, but that chocolate is a behavior that people may generally believe leads to better health outcomes, but it's a marker for a constellation of many, 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 many more behaviors that might lead to that outcome. But in this case, I'm not sure that it really applies, because we have to sort of like roll back the time here. And in 1993, I don't think it was on the popular radar that chocolate might have any health effects at all, other than maybe being kind of calorific and probably not very good for you. And so if that were the case, you would expect the healthy user bias to run in the opposite direction. And so the fact that you see this positive association, that is to say reduction in atrial fibrillation is associated with a dose-dependent exposure to chocolate, actually, oddly enough, makes me inclined to rather believe it.
Yeah, I followed the same logic you did. I did. I can come up with all kinds of problems, but I can't necessarily explain away the effect. And I think that's a key point, is that it's again, we talked about this last time, it's not enough to just say there could be a problem. It's to think about what would that problem do. Right. And in this case, I think you're right. It would actually have made it harder to see an effect when in fact they saw one.
And just to sort of extend this discussion about coffee and chocolate, which I probably would agree. I bet they tend to migrate together because chocolate tastes great in coffee.
I like them together.
Mocha, right? Very popular, right? It's like Reese's peanut butter cups, right? Two great tastes
that taste great together.
Yes, indeed.
Get your chocolate out of my peanut butter.
But the same sort of epidemiologic biases apply to coffee, which has been vilified for decades as being...
Even though we know it is the sweet brown nectar of the gods.
And I'm drinking it right now because I don't buy it. But because, if the popular wisdom is that coffee is bad for you and you see protective effects now you're swimming against the current of the healthy user effect. And it makes me think, like, if coffee is reducing the risk of heart attack and stroke and cancer, it's like, drink up.
Drink up.
Drink up.
All
I'll
right.
buy that one.
There's one other issue that I had with this was that you don't really notice it until you look at the table. And I know we're not supposed to be talking about tables because the listener can't really see the table. But what I think is important is that, and it's understandable, that in the group that consumed very little or no chocolate, the number of diabetics in that group was higher than it was in the other groups.
Right.
And that's completely understandable because if you're diabetic, you don't want to be eating chocolate. That's not a good thing for you. But we also know that diabetes is a precursor or can exacerbate atrial fibrillation. So that made me think, well, it's another possible reason for why this is a spurious finding.
Good point.
And that would work in the opposite of the direction that Chris and I are arguing for. I prefer our theory because it
because you like chocolate and you like coffee.
I like chocolate. All right, so I want to make one last point before we move on.
Objective scientist.
Absolutely, that's how this works. One last point before we move on, which is that what do you make of the size of these effects?
They're smallish.
They're smallish. How would you? 10 to 20% reduction.
Yeah, that's smallish.
That's smallish, depending on what the baseline is. It's a little hard to say. So typically the way we describe effects in literature is we either compare the risks in two groups, those who got the chocolate and those who didn't, and we either subtract them or we divide them. And in this case, the authors have chosen to divide them, which is the typical way to do it. So the only way you can interpret a 20% reduction is if you know off of what base.
Right.
They do not present the base.
Right.
There's
Good
no
point.
risks or rates presented here. Now, you could figure them out because they do give you the data. They give you the number of events, the person years that people are followed. So you could actually go and calculate these selves. But it's just a personal pet peeve that people don't actually talk about actual risk, because what is the risk of atrial fibrillation in a population of, I can't remember what they were in their 50s. What's roughly the risk? I don't know what it is. Is this a high risk event or a low risk event?
That's a relatively low risk event.
Low risk event. So a 20% reduction off of a fairly low risk event is not that much of a difference, such that, okay, let's say in this case it's protected, but let's say it was slightly harmful. It's not going to make me want to change my behavior if I'm getting a small benefit in reduction. It's a significant reduction if you're interested in that sort of thing, but the actual magnitude of the effect is quite small, and I think that's something that certainly the lay press misses. Right? It's just eat 6 bars of chocolate and everything will be better.
Right.
Sort of the so what factor.
Yep.
I know we're going to move on, but I do have one other
want the
thing
last word?
that concerned me in terms of the plausibility of the data and the risk for massive misclassification.
Oh, that's a big issue that we didn't talk about. Yep.
Well, I mean, it's the past chocolate consumption behavior extrapolated for over a decade, and just because they did then 15 years ago doesn't mean they continued forward to do the same. Who knows? But back then, the number of people out of this 55,000 who reported eating chocolate only 1 to 3 times a month, which is an implausibly low exposure to chocolate, was almost half. 22,000 people they don't eat chocolate on a regular basis, and I'm just like, wait a minute,
it's just not possible.
Is just not possible. In Denmark, they have excellent chocolate in Denmark.
I agree with you.
Who are they trying to fool?
I eat chocolate once a month, if that.
Okay, you're off the podcast. You're done.
All right.
I do think. Last word. All right.
I want to add one more thing.
Thea gets the last word.
I just did a Google search to find out other effects that are good effects that are attributed to chocolate, and I found over 35 good effects.
All right.
In terms of decreasing stroke, decreasing cholesterol, protecting skin against sun damage, assisting with weight loss. Apparently, there was a study in Finland which indicated that if the mother ate chocolate during pregnancy, their children smiled more.
Oh, no, that's a given. That's a given right there.
Decreased stress in mothers, prevents diabetes, helps with brain injury, decreases blood pressure. Come on.
It is the magic. Do not say bad things about chocolate.
So it's either like wildly overhyped or it could be true.
Overhyped.
I'm going to say it's
good times are here.
I'm going to say it's true. All right, we got to.
You guys are chocolate chauvinists. That's the deal.
Yeah.
All right, we got to move on.
All right.
So now that we've had our dessert, let's go move on to our second segment, and we're going to talk about the difference between randomized studies and observational ones, like the one that we just read. And so to get us thinking about the differences, Chris, you want to start us off? You want to talk about the difference between observational studies and randomized trials, and then tell us whether or not you are a big fan of randomized trials or observational studies?
Well, wow, that is a bit to bite off there, Matt, but I'll do my best.
You're
welcome. Sure. So, all right. So observational studies are a wide group of epidemiologic studies where you are not assigning exposure or outcome to subjects. You're just sort of letting the chips fall as they may. And I think the study we did today is a great example of that, where we're following a group of people over time to sort of see what happens, and we're measuring things about them. But there's nothing that the investigators are doing other than watching. They're not tweaking the system or doing things in some purposeful way to some group or to another. They're just kind of saying, here's a group of individuals who have a broad range of different epidemiologic backgrounds or features or demographics or what have you. Yep. Things that they like to eat, like chocolate.
It's like a natural history study.
It's like a natural history study. You follow them over time. This being a cohort study, we're following them over time and seeing what happens. And so at the beginning, for example, we see there are some who eat more chocolate than others, and then you follow them over time and you see how many of those people get atrial fibrillation. But it's not an experiment, because there are things about those individuals that may fundamentally differ that could lead to the outcome, which in this case would be atrial fibrillation. Now we get around all those confounders by changing the design to an experimental design. We call that a randomized controlled trial, where we assemble a group of people with a set of features that we think are relevant to that exposure that we're going to test, and then we randomly allocate them to get to this exposure or not this exposure. And the randomization is the key thing, because what it does is that it balances out all of those confounders, or many of them usually. It's not a perfect guarantee, but it generally smooths out the average differences between the two groups, such that the main defining difference between the two groups is whether they got the intervention or the exposure or not. And that is extremely helpful.
So, for example, in the chocolate study, you would expect that if I randomly said you eat chocolate, you don't eat chocolate, you eat chocolate, and so on, that half of the diabetics would end up in one group and half the diabetics would end up in another group, such that you don't have to worry now that diabetes is a thing that explains.
Same with high caffeine consumers.
Exactly. And maybe in this population, there's like this special group of people who have this genetic flavonoid receptor gene mutation that nobody's ever described before that modifies their personal risk of atrial fibrillation. And if you've got that gene, it matters. In an experimental design with randomization, we don't even need to know whether it exists or not, because that will also be randomized. So it deals with all the confounders you know about or think about, and all the ones you don't even know about. In other words, you don't need to care.
Powerful stuff.
It's so helpful. It's so helpful, and they're often more important. So,
okay, Don, give us your take on the randomized trial versus observational studies. Do you believe the results of randomized trials more than you believe the results of observational studies?
It really depends on the question, but in general, yeah, I think randomized controlled trials are really the gold standard at this point in terms of proving that a particular intervention results in a particular outcome. So they're not without problems, but in general, I have a higher level of confidence for randomized controlled trials than for observational studies, because there are all sorts of biases that can be introduced.
That's right.
Chris, what about you? Do you follow that same logic that you're going to believe a randomized trial and you're not going to believe the observational version of it? I
mean, generally, yes. And I think this is one of the things we're going to come back to in future versions of this podcast, is we're going to talk about our little checklists of how we judge the quality of trials. Mm-hmm. But in general, yes, the randomization and the distribution of covariates is a very useful cure-all to get rid of confounding, but not bias.
Okay.
I think one of the really interesting concepts that it took me a while to understand was the concept of a double-blind study. And I always wondered, wow, why are they using scientists that can't see? That makes no sense to me at all.
What's a double-blind study?
So a double-blind study would be a study where the randomization is done, but the participants themselves don't know whether they are in the intervention group or the control group. A double-blind study means that the researchers themselves, the doctors, the nurses, the study individuals, also don't know which arm the particular person is in, because the thinking is that if they did know, they would somehow communicate subliminal cues to the people in the intervention arm or the people in the control arm, and therefore bias or really prevent the effect of the randomization, because they would actually know, and they may act differently.
And so you said that I would, if I'm in a randomized trial that is double blind, I wouldn't know which arm I'm in. So how do I, if I were doing a randomized trial of chocolate, how do I know that I'm not eating chocolate?
Who are you?
I'm the participant.
You're the participant.
Yep.
Yeah, no, you
Some
can't.
studies are hard to blind.
Yeah, obviously you can't. Yeah.
And I think that's
Like
what
a study of the efficacy of parachutes. You couldn't blind that.
No.
would be pretty difficult.
Yeah. And you can't even do a randomized control trial.
That would be
tough.
that'd
I
be
think
true.
that was Warner Brothers in the Coyote episodes.
Yeah, that was a good
Parachute
one.
would actually be an anvil
Yeah,
as the control arm.
you can do that study.
That's wily.
So
Right.
So I think that's where I'm going with this, Don, which is that I share your love of the randomization part of the randomized trial, but the thing that strikes me as when I read randomized trials that I'm not thrilled about is the idea that these are not always very realistic interventions that they're doing, because the conditions are so controlled and the populations that we're doing them in are so different from the general population that I don't always know that what we're getting in a randomized trial, while probably very valid, whether those estimates actually pertain to anyone anyone that would be likely to receive these interventions, or that the intervention could be delivered in any way that actually would mimic what actually happens in the trial.
Yeah.
The other thing I will say, though, in favor of randomized trials that I like, in addition to the randomization issue, is that randomized trials have well-defined protocols. Randomized trials start off with a protocol that describes exactly what the intervention is and how it will be delivered.
Based on a hypothesis.
Based on a hypothesis, and it is well described what the intervention is. So, for example, if you were doing the randomized trial of the chocolate, we would say we're going to ask you to consume, one piece of chocolate a day. By the way, did you notice that they consider 1 ounce of chocolate a serving? I consider that to be wrong.
It's a little low.
That's way low. That's for me. I'm just getting started.
That's an appetizer.
Yeah. And we would tell people consume one ounce of chocolate a day, or we'd tell them consume 2 ounces of chocolate, or whatever it is, so that we could test the effect of a very specific dose of chocolate. When you do this as the observational study, you're just getting whatever people did. And that might have been, I ate an ounce of chocolate yesterday, and I ate 4 bars today and none tomorrow. And I averaged that out, and on average, I'm at 1 ounce, but we don't really know what that means. And so the issue with a lot of observational studies I have is that they often don't pertain to any intervention that we would actually tell people to do. And ultimately, that's our goal for doing this research, is to be able to inform people, hey, if you do consume an ounce of chocolate a day, it's going to reduce your risk by this much. I don't think you can say that with the study that we looked at, because I don't know what the intervention really is. I just know chocolate sort of vaguely seems to be beneficial. That's where I kind of get
The
stuck.
issue really is generalizability on both points that you just brought up, because the findings of a study that, like a randomized controlled trial, is not necessarily generalizable to everyday life.
Yep.
For the reasons you stated, and in the same way, an observational study like the one we're talking about today is not generalizable for similar reasons.
Yeah, it doesn't lead to the well, so what do we do now?
Right. What do we do about it?
You can see the doctor's writing a prescription, 1 Snickers bar, TID.
Yeah, I like that.
Yeah. Okay.
I think the last point I would just make about
Do not take with
observational
meals.
The last point I'd make about observational studies and randomized trials is that with randomized trials, there are certain trials we cannot do, as you pointed out with the parachutes, but let's make this a little more realistic. You can't randomize people to be smoking cigarettes, right? If we want to know the effect we know the effect of smoking on lung cancer, but let's say we want to know the effect of smoking on some other type of cancer that we don't truly understand. We can't do that as a randomized trial. We only have observational studies. And there we just have to do our best to really, really collect information in a way that we can tease out all of those confounding issues that we've talked about. And we need to make sure we measure the information well so we don't get this misclassification problem.
Right. The problem is that it's fiendishly hard to do that.
Incredibly difficult, but that's what keeps us in business.
Yep.
All right.
Job security.
Job security. Okay, so we are now going to move on to our third segment, our wacky science segment. So I'm going to start with Don. Don, what do you got for us?
Great. Well, I think my wacky science segment is going to be dipping from a well of research reports that I found that is absolutely limitless.
Okay.
And is really a wonderful thing. So it's the University of Leicester. In England has, for the undergraduates, as part of their learning experience, what they have is they've got a course where the physicists who are getting their degrees have to write sort of a thought piece on various issues that might arise that they will then calculate their way to an answer. And they write a paper, it's 2 pages, it gets submitted, it gets peer reviewed, and then if it gets accepted, it gets put into a journal called the Journal of Physics Special Topics. Mm-hmm. And there are some absolutely incredible special topics. And I'm just going to go over 2.
All right.
So the first one is a study looking at the Doppler shift of Usain Bolt.
Oh, wow.
Doppler shift. So this is...
So the abstract reads, in 2009, Usain Bolt broke the world record with a finishing time of 9.58 seconds for the 100-meter race at the World Track and Field Championship. In this paper, we calculate the change in wavelength of the color of Usain Bolt's shirt as seen by an observer at the starting point of the race. This phenomenon is also known as the Doppler effect.
Or the Bolt effect.
We find that throughout the race, the maximum change in the wavelength of Bolt's shirt is equal to 2 femtometers.
Oh, the old
This is much
femtometer.
less than the human eye can detect.
So you're saying, so theoretically,
That's
if my eye could detect it, I would, as Usain Bolt is running, I would see his shirt change from red to blue.
And just like the red shift that you
Slightly
see.
less red.
Just like the red shift that you see in stars at night.
Right. I see
So
that
they
all the time.
calculated it, and
That's
they calculated 2 femtometers. Let me do the second
femtometer.
one.
All
The
right.
second one is
Femtometer.
entitled "We Scare Because We Care."
Oh, okay.
So they're taking their idea from the Disney movie, the Pixar movie, Monsters, Inc.
Excellent film.
Excellent film, which focuses on monster pairing Sully the Scarer and his coach Mike. It is the job of the scarer to enter a child's bedroom whilst they sleep, scare them in order to obtain their screams, which are then stored in scream canisters.
Yep, makes sense.
At the end of the film, Sully says to Mike, laughing has 10 times the energy of screams.
Yep.
So Z. Harrison, Mundy, and G.S. Harris calculated the energy produced by children's screams versus children's
A
laughter.
question that needed to be answered.
And the bottom line is, it was estimated that a parent's reaction, the time period spent creating either of these sounds, laughter or screaming, is important as it is required in order to calculate the energy produced. The energy from the child's scream is calculated to be 10.35 joules in comparison to 1.31 times 10 to the minus 3 joules from laughter. In reference to the claim made in the movie, laughter does not produce 10 times more energy than screams. It in fact generates approximately 8,000 times less energy.
Oh, you've got to be kidding. You telling me Pixar is giving me scientifically incorrect information?
Completely wrong.
This
so
makes no
you should
sense.
not be
Can you-
deriving your scientific.
And to be clear, can you convert a joule to a femtometer for me?
No, it's not
Oh, it
possible.
can't be done.
No.
Can't be done. All right. Well, that is upsetting.
And then for
Oh boy, you can't stop him.
for next week, I will be talking about what if it's always sunny in Philadelphia.
Oh, and we know it's not. All right, Chris,
Wow.
over to you.
Wow, I'm not gonna be able to top that.
I know you're not.
That is. First of all, that's a bummer. I am sorry to hear that. But now I know what to do to my kids. We got to get some energy going here.
Right. So you got
Things
to
are
torture
getting-
them is what you got to do. Is to get more energy out of your kids.
Fortunately, they've gone to camp. So by the time they come back, I'll have forgotten all about this. So I found in the journal Science Signaling 2017, the author Annalisa M. Van Hook, who I think is
this a journal
summarized.
you regularly
No. But it's under it's one of the science subjournals.
Sure.
And they have like editor's choice of cool topics, and this one really stood out, which is macrophages don't take more than they can eat.
Unlike me and chocolate.
We are right, the big chocolate eaters. Macrophages are the big chocolate eaters of the immune system, and they their job is to eat foreign pathogens, mostly bacteria, and destroy them.
Yep.
And so the way this sort of works in broad terms is that the macrophage is sort of, you have to imagine as this sort of slimy amoeba-like thing covered with surface receptors that grab onto patterns, molecular patterns that are common in bacteria and fungi. Mm-hmm. And if it sees them, it sticks to them, and then it tries to sort of wrap itself around it. And when it succeeds and completely envelops one of these pathogens, that's called a phagosome. And the contents of the phagosomes are basically what was outside of the macrophage plus the bacteria. So it's just like a little piece of the outside. So that in itself does not kill the bacteria. The bacteria is just as happy in the phagosome as it was outside, right? Yeah. Because it's the same. Okay. So now you got to kill the thing, right? Yeah. And so to do that, there's a multi-step process, as you'd be not surprised to hear, where first of all the phagosome has to connect with another organelle called an endosome, which is basically a little glob of fatty lipid surrounded by chloride channels that are constantly pumping chloride to make a gradient and thereby pulling calcium ions into themselves against the gradient because they're making electrical gradient. And the calcium is very critical here because it's the calcium that later triggers the third step, which is to allow the endosome, which is fused with the phagosome, to then bind with lysosomes, which are the things that are filled with the really nasty chemicals that kill the bacteria. Okay, basically acids.
Yep.
And so you have to have the endosome joining with the phagosome, and then the endosome basically being the on-off switch that tells the lysozymes to come in here and kill this thing that I found.
Yep.
Okay? And this whole process is highly regulated, and there's a multi-step process of signals that go through this. And they have some great names like PGRPLE, which is the pattern generating recognition protein pattern. I don't know what the other is, but it sounds like purple. Which activates an enzyme called relish.
Relish?
Relish.
Ooh, I like that.
Which is you think of little chopped up vinegary pickles on top of your bacteria.
Yep.
And so the relish activation, which is an analog enzyme of NF-kappa B, which is a signaling process.
No idea what that is.
It's a little molecule that goes into the nucleus of a cell and says, DNA of relevance, turn yourselves on and do this thing. And the whole cascade of these events leads to an upregulation of this relish enzyme that turns on the enzymes that allow you to make the macrophage to make more of these things that bind the calcium and bind the lysosomes and all of that, the whole process. And the trigger for this is bits of dead bacteria. So the more the macrophage eats, the more it synthesizes the machinery to eat more bacteria. So it's a feed-forward controlled mechanism.
And the wacky part
is? Like me with chocolate.
Exactly.
Again.
So basically the bacteria, the macrophage regulates the amount it can eat by the amount of food it's given in the form of bacteria. It is totally cool.
I think that's fascinating.
Anyway,
I think we have to have the next podcast after lunch so we're not completely obsessed about eating.
I think you're right. I think I'm also...
So I thought that was nifty.
I'm also starting to notice a theme here when it comes to these wacky science. Don, you go for the most absurd thing you could find. Chris, you go for the elevated concepts. Let's see where I go with this. Okay, so for my piece of this, I found something that just made me quite happy, which is that there was you've heard me talk many times before about the peer review process. Peer review process is the process by which journal articles on these of the type that we read for the first segment get published, is that they get submitted to a journal and then they get sent out to experts to review them, and they try to poke holes in them, come up with all the problems and send it back to the authors, and they get a chance, typically, if they think it's a good enough paper, to respond to those comments, and if they can respond and fix all the problems, then it gets published. And typically, a reviewer is asked to make a recommendation as to whether or not this thing should be rejected, accepted, need more information, that kind of thing. Well, and it for those of us who are submitting journal articles, it can be a harrowing process because you put your life into this paper and then you send it off to people who probably don't spend as much time on it as you would like. Then
quickly decide they hate it.
Probably decide they hate it and
make snide comments like we do.
And make snide comments about it. Exactly. So there is a group in Moscow at the Moscow's Higher School of Economics. And there was someone there who had I think it was like a Kickstarter campaign to raise money $2,500 to build a monument to peer review. And they have made a monument. It looks like it's a cube that looks like a die. What's the singular of dice? Die. One die. That has on it all of the major categories that you can give to a peer-reviewed paper. So they've got major changes, minor changes, accept, revise, and resubmit, and reject. And, this presumably is the way it works. Somebody gets your paper, they just roll the dice, see which one comes up, submit it right back. So I really
like that.
Wow. I really like this, and I like that somebody.
Are staggering.
They are staggering. I love the fact that somebody has the sense of humor in Moscow to put that togetger.
So they have peer review in Russia?
Apparently so, yeah.
Wow.
Apparently so.
So I always thought that peer review was something that happened at seaports.
No. That is a different kind of peer review.
All right.
So that's the end of our program. If you've got any feedback on this or any other show that you want to talk about or suggest a topic for us to take on, you can tweet us at pophealthex. That's at pophealthex. Or you can find us on the Population Health Exchange website. Thanks for joining us. We hope you enjoyed it, and we hope you download the next episode.